In this example, we're going to take a look at the blue f of x function given in the figure, and we're going to try to explain why the limit as x approaches 1 of f of x does not exist. Here, we can make an explanation through one-sided limits. The definition of a limit states that if we want to evaluate the limit as x approaches 1 of f of x and set it equal to some limit, capital L, that means that as x gets close enough to 1 from either side of 1, then our f of x values have to get pretty close to capital L. So what's happening in our one-sided limits in our picture? Well, looking at x values that are a little bit bigger than the number 1, we can trace along our f of x function, and we can see that the limit as x approaches 1 from the right of the blue function tends towards a y value of 3. On the flip side, we could also take a look at x values that are a little bit less than 1. So tracing along our blue function for x values a little bit smaller than 1, we end up with a y value of 2. So what does this tell us? As we start approaching 1 from the right, we get y values that are arbitrarily close to 3. And as we approach 1 from the left, we start to get y values that are arbitrarily close to 2. Now this puts us in a little bit of a bind, because if we choose the limit to be equal to 2, then we can't really get any closer to 2 on the right-hand side than the number 3. And similarly, if we try to choose the limit of 3, but we can't really get any closer to 3 than the number 2 if we start approaching from the left-hand side. So since the value of the limit is dependent on the direction that we approach the x value of 1 from, we're going to say here that the limit does not exist. And the way that we write that down mathematically is we write the limit as x approaches 1 of f of x DNE.